Today I'm going to review the procedure involved with the creating a water filter lab. Now the overall objective of this lab is to find an adsorbent material which is most effective at removing contaminants in uh, dirty water, thereby creating some purified water for drinking. The specific objectives of the lab are to test a variety of materials for their ability to be adsorbent. And once you determine which of the materials is the most effective on a small scale, you're going to go proof of concept to something larger. Now, these are just simply water purifiers that I created using the 3D printer. The idea is once you identify which material is the most effective, you pack that material into this part of the water filter. There are some small holes in the bottom, and then you put a plug on the other end. The plug also has small holes, and then this part of the water filter is threaded, so it actually sits right into a jug of dirty water. You screw it in, and then turn the jug upside down. As water goes through your filter, it's purified on the other end. So the scientific method part of this is to determine which of the materials you test is the most effective in removing contaminants from the water. There are a variety of substances that you're going to be trying to remove from the water. Right? Water is a great solvent, so lots of things dissolve in it. That's important for living things, but it cuts both ways. A lot of times the things that dissolve in water we don't want in our water when we drink it. So I've created some simulated dirty water. I didn't just get this out of a cesspool behind the school. I actually created this, added some things that give it a little bit of color, a little bit of odor, which sort of simulates the presence of bacteria. So your filter ideally would also remove bacteria and viruses, which are important to remove from water unless you think cholera is fun. And so you're going to be testing the ability of these materials to filter out all of those things, sediments, dissolved substances, even the odor that this particular water has, by comparing the dirty water, which I have a sample up here, to the clean water, which is going to be created, or cleaner water, which is going to be created with your individual water filters. So the materials that you can use to test include, in this case I have some sort of activated charcoal. It's fairly chunky particulate charcoal. I have some shredded coconut husks. This is actually bedding, which is used for invertebrates and reptiles. This is also bedding material. This is crushed walnut shells, but this is much finer. I have some crushed corn cob. That's fairly coarse material, also animal bedding material. And finally, I have some sand. And sand is what I'm going to test right now. I'm going to quickly create a water filter. The water filter that you're going to use for testing is made from these plastic disposable transfer pipettes. And you're going to pack the material you're testing into the barrel of the pipette and then pour dirty water through it and then catch it in a test tube. To create this, you need to cut the top off of the test tube. This part right here, don't cut it down close to the bottom. You want to leave as much as possible. So I'm just going to cut that right now. Now, each of these materials will be at those white tables at the back of the classroom. Those are kind of common lab benches. I would ask that you choose your materials, go to the lab bench, pour it into the plastic weigh boat and bring it back to your lab bench. Do not bring these stock beakers. The reason is, first of all, I don't want any cross-contamination, but secondly, when people take these back to their lab benches, nobody else knows where they are. So I've walked back to the white lab bench or lab table. I poured in this case, some sand into my weigh boat. And now I bring it back to my lab bench. And to create the water filter, it's just this easy. I'm going to bend the weigh boat to form a bit of a funnel shape. And then I'm actually going to use a plastic funnel to simply, actually this minimizes the mess and spill of the sand on your lab bench. You just pour it into the funnel and it fills up the plastic pipette. In this case, I've actually overfilled it, so there we go. I should pour a little bit of that back into my weigh boat. There we go. Now, before you actually pour any of the water through your water filters, you need to collect some data on the water. You need to look at things like the color of the water, the clarity of the water. Now, those are somewhat subjective measures, but still, you can compare the water before and after in terms of its color and clarity, much like a diamond. You can also detect the odor. You can see if there's any suspended material in the water, and then you can use the conductivity probe to measure dissolved ions. It's really simple to use this conductivity probe. Simply remove the end cap, turn it on, and then insert it into the solution. You want to insert as much of the probe as possible, those two little metal probes right here. So to do that, I'm going to tip the beaker on its side and insert the probe in. Now this is not like the thermometer where as soon as the mercury or alcohol in the thermometer gets to the temperature of the water, it stays there. As the water moves back and forth across the probe, the numbers will change a little bit. So you're going to get it approximate. Right now this is going between 13 and 1400. Actually, right now, it's pretty close to about 1500 parts per million. You're also going to test the filter material once you're done. It's important to rinse the conductivity probe between trials. You can do this under the faucet if you have a gentle stream of water. Key word here is gentle, don't blast it. Rather than go over to the sink, I'm actually going to do it right over my beaker using a squirt bottle of water. Just be sure you rinse off anything that is on the probe from the last test. It also helps to blot this dry, especially if this is the last time you use it before you put it away. Just blot that with a paper towel and put the end cap back on and turn it off. Now, to test the water, I'm using another plastic transfer pipette. This is a 1 ml pipette, and I'm going to transfer 3 mils into my sand. So I just squeeze, pull up 1 full milliliter, add it to the top of my pipette. Be very careful that none of the water runs on the outside of the pipette. I'll show you. You don't want any water to run down the outside of the pipette because then it just runs all the way down and right into the water which you're purifying. So you're mixing dirty water and clean water if it runs over the pipette. So I'm going to pour 1 milliliter in, 2, and 3. Be careful it doesn't overflow for the same reasons. And then leave that to flow through the filter. It's not going to be instantaneous. It does take a few minutes. This is one that I did a few minutes ago. The water has now collected in the collection tube. At this point, you can remove this, and if you're completely done with your filter, you can throw it away. But now you also want to test this water in comparison to the original dirty water. I think you can maybe see it's not perfectly pure, but it is a little purer, a little cleaner than the water that went in the first time. So again, what you're trying to determine is which material is the most effective in purifying the water. Once you're completely done, you can pour these solutions down the drain. There's nothing toxic in your solutions, either dirty or pure. And you can throw away the plastic pipettes. You do need to make sure that you wash these thoroughly. Each of your lab stations should have a bottle brush, so a little bit of gentle soap and water with the bottle brush will make sure that these test tubes are thoroughly clean. A clean test tube can now be placed upside down in the tube rack to dry. It really is important that you clean those test tubes thoroughly because the next group needs to have clean test tubes so they don't have any contamination. Once your lab station is completely clear and clean, the pipettes are disposed of, the test tubes are clean, all the materials are put away, you are now free to start the lab report. Yay, lab report.